In this video, we're going to look at another fill-in-the-blank problem. The problem states, fill in the boxes with distinct integers 0, 1, 2, 3, 4, 6, 7, 9, so that the following two equations hold true. The two equations are, the first one, box plus 8 equals box. The two boxes together represents a two-digit number. So a two-digit number plus 8 equals another two-digit number. Second equation is box, a two-digit number, times 5 equals box, another two-digit number. Now we have 8 boxes, and then there are 8 numbers. Each number is going to a different box. Now, if you look at the problem clearly, the 8 digits are really 0, 1, 2, 3, all the way 9, except 5 and 8 are already used here, so it's removed from the 10 digits, 0 to 9. So how we approach this question. Please allow yourself several minutes to try it. Again, to solve this kind of questions, the key is to find a key constraint. And for this question, the first constraint is pretty simple. Actually, it comes from the second equation. You have a two-digit number multiplied by 5 equals another two-digit number. The key is, what is this digit? We know that for multiplication 5 property is, if something multiplied by 5, the number is going to end with either 0 or 5. But we know that the 5 is not in the list of integers here. So this has to be 0. Okay? This one is a 0. I put here. That's the first clue. Pretty obvious. So now we have left with 7 numbers. And with that, actually, this digit is also pretty simple. You see, this number cannot be more than or equal to 2. Why is that? Because a 20 times 5 is going to be a 3-digit number. And of course, this digit cannot be 0 for 2 reasons. One is 0 already used. That's good enough. The other one is a 2-digit number is not going to start with a 0. So this digit has to be a 1. Actually, let's just put the 1 there, okay? And put a 0 there. So we got the 0, 1. We can cross now. We have 6 boxes now, and with 6 digits. And we know that there's going to be a 1 times something, 1 something, not 1 times something, 1 something, a 2-digit number, times 5 equals a 2-digit number, ends with 0. So we know that this digit is going to be an even. The even digits there are possibly 2, 4, 6. And here, we know that this number is going to be 1 something times 5, 1, 2, 1, 4, 1, 6. So this number is going to be either going to be 6, a 7, or a 9. Right? That's what we got from the second equation. How we proceed after this? But wait a minute. If you look at the first equation, this is a 2-digit number plus 8 equals another 2-digit number. By removing this 0 and 1, we know that this digit is going to be at least 2. So what do we have? A digit here, at least 2 plus 8. It means that this digit, when you add it, this digit is going to be 1 plus this digit, right? So the single digit will go, add up to be more than 10, and that will add 1 to the 10th digit. All right, so we have another very important clue. These two things are going to be consecutive integers. With this important clue, let's see what these two numbers can be. Well, consecutives, there are actually 3 pairs. Either this will be a 2, 2 goes there, and 3 goes there. Or 3, 4. 3 goes to the first place, 4 goes to the second place. Or 6, 7. 6 goes to the first, 7 goes to the second. These are the only 3 pairs of consecutive integers after you remove 0 and 1. Okay? And we might be able to using those 2 constraints, like this has to be a consecutive, and here you have to using 2, 4, 6 here, and 6, 7, 9 here. All right, but with those limited constraints, a clear way is just do trial and error. So let's just do trial and error. The first case is the first digit is 2, 2 something plus 8 equals 3 something, and 1 something times 5 equals something 0. Okay, and the remaining digits are 4, 6, 7, and 9. And with that, let's see how we go from here. So you either can put the 6 here, and this will be a 9. And then this has to be, goes using 4 and a 7. 4 and a 7 here. And does not matter you put a 4 here or 7 here, this is not going to give solutions. So 6, 9 is not good. How about I put 4 here, and this has to be a 7. 14 times 5 equals 70. So now you have 6 and 9 here. And that's also impossible. Actually, you can see from this, because this is going to be a 2 something plus 8. So if this is odd, this has to be odd. But using 6 and 9 or 4 and 7, it cannot be, one is odd, one is even. So this is impossible. Okay? How about second case? The first digit is a 3. The second digit is 4. So you have 3 plus 8 equals 4 something, and 1, this times 5 equals this 0. And the remaining 4 digits are 2, 6, 7, and 9. All right, so again, that these two in here, by the same logic as I just described before, these 2 digits has to be both even or both odd. So either can be 2, 6 or 7, 9 here. But from here you have, this is only can be either 6, 9, but that will remove the 6, 9 from here and left with 2 and a 7, which are not even odd. So 6, 9 is not good. So in here, if you put 1 and 2 here, 12 times 5, that gives you 60, right? This is going to be 6. So you're left with 7 and 9. And in here, you put 9, 39 plus 8 equals 47. So this is one solution. We found one solution. Okay, this is good. The third case we're going to try is that this digit is a 6 and this digit is 7. So 6 times 6 something plus 8 equals 7 something. And 1 box times 5 equals box 0. And the remaining digits are 2, 3, 4, and 9. Now, this is impossible because you cannot find a 9. If the 9 is here, this has to be a 6, but we don't have a 6. If 9 is here, this has to be a 7, but 7 is already used. If 9 is here, this has to be a 1, but we know 1 is used. So this also, there's no solution. So we only have one unique solution, is 9726. And the whole answer is this is a 39 plus 8 equals 47. And here is 112 times 5 equals 60. A bit of review of this problem. Where's the key to solve this question? The first key is actually pretty simple. You observe that 1 box times 5, actually a box times 5 equals box. Because of the property of multiplying with 5, you know this digit has to be 0. And because something multiplied by 5 equals still a 2-digit number, this first digit in the second equation has to be a 1. So you constrain these 2 digits, 1 and 0. And now you're left with 6 digits to fill the other 6 boxes. The second key observation is a bit of implicit. You observe that 2 digit add an 8. Now, most of the time, adding an 8 is going to result the 10 digit increase by 1. Unless this digit is 0 or 1 here, right? But 0 and 1 is already used. So this has to be this digit equal this digit plus 1. And so from this, we know that these two as a pair has to be consecutive integers. But if you look at what's remaining, 2, 3, 4, 6, 7, 9, there's kind of a break there. The consecutive is only 2, 3, 3, 4, and 6, 7. With that constraint, we just go ahead by using trial and error. There are only 3 cases to try. Instead of at the beginning, there are many cases you have to try. Here, only 3 cases. And with that 3 cases, once you have put another 2 digits put there, you only have 4 boxes left. There's only very limited cases you need to go through. And it can be done fairly quickly. So again, to solve those fill-in-the-blank problems, the first step is always trying to understand the problem. Look very carefully, what are the choices of the digits? And then trying to find the key to limit certain boxes. You say either using some boundary, like the first digit cannot be too big, or the last digit only can be 0 or 1, or some boxes that multiply and divide has to be an integer, to limit those choices. With that limitation, if you can pin down 1 or 2 boxes, the problem just becomes so much easier. And that's something that you should always keep in mind. And by doing more exercises, I'm sure you will get that